Right now here in New York City, the temperature is 97 degrees Fahrenheit or 36 Celsius, which is close to the all-time high for today's date, July 29th. It's definitely hotter than normal, but then again, these days, normal isn't really normal anymore. We know climate change is bad. It already is bad and it's only getting worse. Droughts, floods, oceans rising, crop failures, diseases, and hot days like today, they're only getting hotter. But big picture, how bad could it get? Bad enough to cause a global catastrophe? These are important questions, and this video will provide some answers, but first, I've got to get myself back inside before I become yet another victim of extreme weather.
That's better. Okay, actually, I filmed that outdoor segment about a month ago, but whatever. So, these topics are at the heart of what we study at the Global Catastrophic Risk Institute, a nonprofit and nonpartisan think tank. Is climate change a global catastrophic risk? Well, what is a global catastrophic risk? The death of millions of people. The death of billions of people. The death of 10% of the world's population, or 25%. These are all among the ways that global catastrophe has been defined in the research literature. And it's fine to have so many definitions. It's just language. We can define words to mean whatever we want. A pet peeve of mine is when someone says something like, a global catastrophe is the death of 1 billion people. No, that's not what it is. That's just one way that it can be defined. Personally, I think those previous definitions, a billion people, 10%, things like that, to me they're too arbitrary. Why 1 billion and not 2? A less arbitrary definition is the collapse of global civilization. And by that I mean the world that we all live in stops functioning. No more global supply chains, no more electricity except maybe in a few isolated places. Industrial agriculture fails, and with that, most of us are probably dead. If there are any survivors, they might be subsistence farming or hunting and gathering, living a much simpler and less comfortable life than what we can enjoy right now. So, could climate change do that? Put it this way. The human species has been around for maybe 200,000 years, but we didn't develop agriculture until the last 12,000 years, give or take. And within these last 12,000 years, we didn't just develop agriculture once. We did it a bunch of times independently in different places around the world, places that didn't have any communication with each other. Why? Why would we go 200,000 years without developing agriculture anywhere, but then in 12,000 years we do it multiple times over in different places? We don't know for sure, but one theory which seems to have some pretty good support for it is climate. Over tens or hundreds of thousands of years, Earth's climate naturally changes due to little quirks in how Earth orbits around the sun called Milankovitch cycles. They're caused by Earth getting little gravitational tugs from the other planets and objects in the solar system. This gives us the ice ages and things like that. Over the last 12,000 years, we've had a relatively nice, warm, stable climate period called the Holocene. So, the theory is maybe we didn't develop agriculture before because the climate wasn't good enough, but then the Holocene rolls in and boom, we're growing food and civilization takes off from there. But now we may be pushing the climate outside of those nice, warm, stable Holocene conditions into something warmer than the human species has ever lived in. So, could climate change cause the collapse of human civilization? Maybe. But let's look at some details. So far, the planet has warmed by about 1 degree Celsius or 2 degrees Fahrenheit relative to what it was before the Industrial Revolution, before people started burning lots of fossil fuels and putting lots of greenhouse gas into the atmosphere. This map shows an extreme climate change scenario with warming of 12 degrees Celsius or 22 degrees Fahrenheit. Now, I want to be clear, this is very much on the high side of what we might get. And if it does happen, it may take a few centuries to get there. But when we're talking about catastrophic risk, it often is a small probability of some catastrophically bad event. And this map this is bad. The green areas, that's where the weather would be cool enough for people to be outside year-round. In many of the places that people live in right now, for at least parts of the year, we would struggle to survive outdoors. We could survive indoors, but only with air conditioning. This would also affect other mammals, including livestock animals like cows and pigs. And I think it would also apply to birds because they're also warm-blooded, though the research I've seen doesn't address birds, and even among mammals, each species handles heat a little differently. By the way, if you want to see the research that this map is based on, and the research behind everything else in this video, it's in a write-up on the GCRI website, link in the description. So, would this cause the collapse of human civilization? First of all, no one really knows. It's so different from our current world that it's hard to study, but also, no one's really studied it much. These more extreme scenarios have been systematically underrepresented in climate change research, including by the IPCC, the Intergovernmental Panel on Climate Change. Instead, climate change research has mostly focused on relatively small amounts of warming, which is fine if we only get smaller amounts of warming, but if we don't, we're kind of flying blind, and that's a problem. My group, the Global Catastrophic Risk Institute, we could do more if we had more funding, but we also want to encourage the broader research community to work on this. You can also help us out for free just by subscribing to this channel. So, would civilization collapse? Maybe. It's certainly not hard to imagine it in this radically different world. We might be able to keep civilization intact, but there's just so much that could go wrong. So, if we define global catastrophe as the collapse of global civilization, then this scenario would seem to pose a global catastrophic risk. But doesn't that feel kind of wrong? To say that this scenario, this radically diminished world, would only be a global catastrophe if civilization collapses? In other words, we lose half the planet, but civilization's still intact, so it doesn't count as a global catastrophe. I'd say that's a problem with this definition. There's an even more problematic definition out there for the related term existential risk. Some people define existential risk as the risk of something that would destroy humanity's future potential. The problem is, even if civilization collapses, that may not destroy our potential, as long as there's at least a tiny chance of some people surviving and rebuilding. I think it should still be a risk as long as there's a chance of the bad thing happening, even if there's also a chance that it won't. Another definition we sometimes use at the Global Catastrophic Risk Institute is the risk of an event that would significantly harm or even destroy human civilization at the global scale. Now, that's a bit vague. What does that mean, significantly harm? There's no clear threshold for that. But however we might set it, it could include this extreme climate change scenario, losing half the world, and so on. There are also some other climate change scenarios worth talking about. One is geoengineering, which means engineering the planet. There's a few different types of geoengineering, but the one that's relevant here involves putting little particles up into the stratosphere, which is the second layer of the atmosphere above the clouds. Those particles would block some of the incoming sunlight, which reduces temperatures at the surface. If we need to avoid warming of 12 degrees Celsius or 22 degrees Fahrenheit, or even much lower amounts of warming, this would probably work. Now, there would still be changes to the global environment. It's not the same as if we just didn't put the greenhouse gases into the atmosphere in the first place, and that would cause some problems. But to avoid extreme warming, it would probably work. But there's a catch. These particles that we put into the stratosphere, they fall back out after a few years, and so we have to keep putting them up. And if we stop, we get the full blast of sunlight again. Over the course of just a few years, surface temperatures rise to whatever they would have been without geoengineering. Rapid warming is harder to adapt to, so it could cause more harm than without the geoengineering. Rapid warming of 12 degrees Celsius or 22 Fahrenheit, or really anything in that direction, Would civilization collapse? Again, we don't know, and we haven't done much to study it, but maybe. I certainly wouldn't want to try it and find out. And finally, one more scenario with normal climate change, meaning no geoengineering and only small amounts of warming, maybe just 2 or 3 degrees Celsius or 3.5 to 5.5 degrees Fahrenheit, which we are already well on our way to causing. It's not hard to tell stories of how small amounts of warming lead to the collapse of global civilization, especially when we account for other global catastrophic risks. For example, pandemics. A primary way they start is zoonosis, where the virus goes from other animals to humans. That's the leading theory for how COVID-19 started. The issue is, climate change is shifting where wild animals live, so we get species that weren't previously having much contact with humans, but with climate change they are. We also get different mixes of species in contact with each other, passing their germs back and forth, causing new mutations of the viruses, which could then cross over to humans. Some of this is already happening. For example, over the last few years, there have been some outbreaks of dengue fever in mainland France. Dengue fever, that's a tropical and subtropical disease spread by certain kinds of mosquitoes that didn't used to be in France. Now, that's not a pandemic, but still it shows how this works, and it's going to get worse even under small amounts of warming. So, is climate change a global catastrophic risk? We've now seen 3 different scenarios of global catastrophe in which climate change plays a central role: extreme warming, geoengineering, and pandemics. And there are others, for example, involving nuclear weapons or artificial intelligence. But, and I really want to emphasize this, across all these scenarios, there's a lot of uncertainty. We don't know how much greenhouse gas we're going to emit. We don't know exactly how the emissions will affect the climate and how human populations will adapt. We don't know if we'll ever try geoengineering, and if we do, we don't know whether we'd stop putting the particles into the stratosphere. And we don't know how climate change will affect disease outbreaks and all sorts of other things. Sometimes people say because there's so much uncertainty, we shouldn't worry about it. But that's backwards. The more uncertainty there is about climate change, the more likely it is to be a global catastrophic risk. At its core, global catastrophic risk is the risk of harm so large that it exceeds some threshold. Each definition sets a different threshold: 1 billion deaths, the collapse of civilization, etc. More uncertainty gives us a wider spread for how bad it could be. It might end up being not that bad, or it might end up being so bad that it exceeds the global catastrophe threshold, however that's defined. We can't rule out these possibilities. More research could help us to narrow the spread and better clarify whether climate change is a global catastrophic risk, but meanwhile, because there are some very plausible scenarios in which climate change leads to global catastrophe, I think we have to say yes, it is a global catastrophic risk. But it's a little more complicated than that. Except maybe in the extreme warming scenarios, climate change isn't causing global catastrophe on its own. Instead, it's doing it with other things like geoengineering or pandemics. So, is climate change the global catastrophic risk, or is it geoengineering or pandemics? I would say yes, they all are, together. And this is a running theme. People often ask me, what are the biggest global catastrophic risks? But you kind of can't answer that because the risks aren't really separate. Also, ultimately, I would say the important part is not which risks are bigger, but instead it's what we can do about it. You could have the biggest risk in the world, but if we can't do anything about it, what's the difference? So, instead of asking, is climate change a global catastrophic risk? A better question is, does putting more greenhouse gas into the atmosphere increase the risk of global catastrophe? And I think the answer is clearly yes. Therefore, to reduce the risk of global catastrophe, one thing we can do is to reduce greenhouse gas emissions. But here's the thing. Do we really need all this analysis of global catastrophic risk to reach the conclusion that we should try to reduce greenhouse gas emissions? No, definitely not. You could completely ignore global catastrophic risk and it would still be a good idea to reduce emissions. But if you are someone who is specifically motivated to reduce global catastrophic risk, then it is worth recognizing that reducing emissions helps. A big reason why I want to make this video is because climate change is a great way to study the definition of global catastrophic risk. Indeed, a core purpose for these videos is to help people learn some fundamentals of global catastrophic risk, including people who might want to get involved. If you want to get involved, check out the GCRI Advising and Collaboration Program, link in the description. Also, sometimes people active on global catastrophic risk don't take climate change seriously, and I want to push back on that. We should take climate change seriously. And finally, a better understanding of climate change as a global catastrophic risk does help for some decisions. For example, how should we adapt to extreme warming? Or, under what circumstances, if any, might geoengineering be a good idea? And how can we monitor shifts in wildlife populations to manage a changing pandemic risk? Still, it's important to recognize that these aren't two completely different types of risk, global catastrophic risk and everything else. It's all part of the same world with greenhouse gas emissions and viruses and so on. It's very important that we avoid global catastrophe, but when you really dig into the details, we often find ourselves addressing other risks and issues at the same time, which is all the better. Thanks for watching.